Okay, so lana ngiphethe question 2 from a November 2018 question paper in physical science. This is a grade 12 question paper. This is a grade 12 question for Newton's second law, but I feel like it's also relevant to look at for my grade 11. So yeah, solving the question. Now, question 2 ifundeka ngale ndlela le. The block of mass 8 kg is placed on a rough horizontal surface. The 8 kg block, which is connected to a 2 kg block by means of a light inextensible string passing over this friction passing over a light frictionless pulley, starts sliding from point A as shown below. So lana kule sketch basikhombisa the 8 kg block seku point B, but imove from A yeza ku B, so expect ukuthi futhi ifike nakubani naku point C. All right, let's check the first question. The first question but state second law, Newton's second law. So in this video I ngeke state, but ngizombhala in the description below of this video. So lana kahle ngifuna ukufocus on ama calculations kakhulu. So 2.2 asenze 2.2 2.2 but you see draw a free draw a label free body diagram for the 8 kg block. Okay, this should be easy. This is supposed to be easy. So qala the normal force, because the 8 kg block is ihleli phezu kwe horizontal surface, so there must be a reactive force, a pointer upward. So the first one is over a normal force, the next one bese kuba yi weight or Fg. Well, it's weight, but I represent as Fg, the gravitational force, or as weight, and then uzoba nani tension is experience a tensional force as draw also this horizontal line, and then lana sine 15-degree angle. Now ngoba the 8 kg block is placed on a rough horizontal surface, so the 8 kg blocks you expect to you experience a frictional force as well. So let's represent that as what? Fk, the kinetic frictional force. Yes, it's gonna be the kinetic frictional force. And once the 8 kg block starts moving, you experience what we call a kinetic frictional force. So I represent as Fk as well, or Ff, or something like F frictional force, right? I represent that so. Okay, and then check out my marks Latin for 4 marks. So it's gonna be 1, 2, 3, 4. If you have anything less, and then ubona ama marks wakho athi 4, let's say mhlawumbe una 2 yama forces ku free body diagram yakho, know that ukuthi you are missing some forces ku sketch sakho. So lena it's for the 8 kg block, free body diagram for the 8 kg block. So now the next question, 2.3. Go 2.3, but when the 8 kg block reaches point B, figure la B, the angle between the string and the horizontal is 15 degrees, and the acceleration of the system is 1.32 meters per second squared. So the 8 kg block was moving from A to B. During that instant, the 2 kg block was also going down. So in other words, it has got the 2 kg block, it does the 8 kg block. So that's why I move it from A to B. So in other words, the system accelerator to the right for the 8 kg block, and then downwards for the 2 kg block. So 2.3.1. 2.3, 2.3.1, 2.3.1. So lana bathi give a reason why the system is not in equilibrium. First of all, as understand what's the meaning of this word equilibrium. Equilibrium because it's static, non-moving, no movement, inactive, right? So why is the system not in equilibrium? Because of the system is doing what? It's accelerating, right? That's the reason why. Because the system is accelerating, right? Or singathi also an accelerating system. An accelerating system, it also means there's a non-zero force acting on the system. That's why you accelerate the system. Ne? Sorry man. That's why the system is not in equilibrium. For 1 mark. 2.3.2. Use the 2 kg mass to calculate the tension in the string. Okay. Newton's second law. This is a two-body system. So in a two-body system, expect ukuba na two yama equations. Sorry. Expect ukuba for a two-body system, expect ukuthola two values, the acceleration as well as the tension. So in other words, uzoba na two equations so kwamele uwasolve simultaneously. So in this case ngoba basiphi acceleration, so in other words asekho isidingo sokuthi calculate acceleration, anyeke sasolve ama equations simultaneously. So basenzela ubulula basipha lelo kanje le acceleration le. So into soyicalculate nje for this system kuzoba i-tension nje kuphela, ne? So sizosebenzisa the 2 kg mass to calculate the tension in the string. For how many marks? 3 marks. Okay, the question lena I recommend ukuthi ulo kanje draw the free body diagram for the 2 kg mass as well. So sizothi for the 2 kg mass sizoba no weight or Fg as well as the tension in the string. Naila, the 2 kg mass experience its own weight as well as the tension in the string. So na into so yenza ke la. Sina 1 and 2 yama forces la. There's no mark for this, but for the sake of setting up my equations and doing the calculation is okunceda the free body diagram. So this is for the 2 kg block. This is for the 2 kg block. The free body diagram. So bheka, also the system is accelerating. So in other words, sizo apply a second law. F net is equal to ma, right? Now uzodinga ukuthi calculated the resultant force or the net force between lama forces ayi-2 lawo, ne? And remember, let's choose downward as positive. It's important now when Newton's laws choose a direction. So let's take down as positive. Let's set up our equation. So let's substitute to F net. To F net to tola the sum of these two opposing forces. So tension is over negative. I think so Fg uzoba positive ngoba ubheke phansi, and then tension uzoba upward, uzoba negative ngoba upointer upward. So it's going to be equal to ma, right? Now Fg, also siyazi ukuthi Fg is equal to mass times gravitational acceleration minus t, which is the value esifunayo, equal to, let's substitute to m wethu. M nangu it's 2 for the 2 kg block, and then acceleration here too is positive 1, 3.2. Remember, system yethu yaphi iyaphansi system angisho iyaphansi ngoba basitshelile ukuthi la the 8 kg block reaches point B and then the acceleration of the system is this. So it was the system the accelerator from A to B uma ubheka the 8 kg block. So for the 2 kg block the system is going down. So lana again, that's why it's positive 1.32. So I substitute the lana for the gravitational force. It's 9.8. It's positive nala. No positive ngimsusile ngoba it doesn't matter ukuthi ukhona or akekho la, ne? Just for the sake of clarity, athi ngimfake positive minus t. Bheka ke manje. Lena ngeke ngicalculate, athi ngibhale la phansi nakhona. Ngeke ngicalculate just yet. Athi ngibhale la phansi. So now, so ne linear equation ke manje, you have to solve for the value T or the tensional force. The tensional force. So let's calculate lama values here now. Let's calculate lama values. 2 times 9.8 16 or 19.6 minus T equal to 2 times 1.32 equal to 2.64. So sizothi ke, let's try. Okay, nginama-like terms now, and then T, which is the value engifunayo. So in order to solve the equation, you transpose lo T to the right hand side izoba positive bese ngishiya lo 19.6 bese ngitranspose the 2.64. so answer yami izothini 19.6 minus 2.64 equal to 16.96 equal to tension. It's measured in newtons. Actually it's a force. Direction up. Okay, umunye umntwana ngabuza ukuthi okay, why answer yakhona iphuma ingabi negative ngoba uthi ubheke phezulu? The reason for the answer yethu ukuthi ingabi negative, it's because the time is set up equation yethu already bese sifakile ini ama signs for lama forces wethu. So answer yethu izophuma i-positive nangabe i-equation yakho isete ngaleyo ndlela le, right? Okay, now let's see the next question again. 2.3.3. Calculate the frictional force between the 8 kg block and the horizontal surface. Okay. It's for now the frictional force. 2.3.3. I think redraw this free body diagram for the 8 kg block. It's tension, normal force, frictional force, which is the value esifunayo, weight, and then 15 degrees. And it's 15 degrees, the angle between, it's 15 degrees. Okay, I hope you have all, guys. Okay, now it's for no calculator the frictional force. Bega lagle sketch it. Ngoba 8 kg block move from A to B. Kazi go to F net to actor horizontally. That's why the block is moving from A to B, and then eventually it's taller ini. Basically, the system ya accelerate ngale value le, ne? So bega kazi go to sizodinga the horizontal component for the tension. Sizodinga the horizontal component for the tension. So bheka ke manje asithi this horizontal force or this horizontal component for the tension is gonna be let's say tension X is equal to T multiplied by cos. Now usebenzisa ama-trigonometric ratios wakho. The horizontal component uyithola ngo-cos, the vertical component uyithola ngo-sin. Angisho, this is your hypotenuse triangle yakho. Opposite over hypotenuse izokunika u-sin. Adjacent over hypotenuse izokunikeza the horizontal component. Angisho, that's why siba nalama values lawo. So now it's important to calculate nale horizontal component for the tension. So bheka ke manje, F net, remember 8 kg wenzani uya accelerator ngisho. So apply second law always. Now set up equation yakho, especially for second law. You always have to write this formula down, ne? And then we calculate to F net wakho ngoba 8 kg block accelerate experience a net force in the horizontal plane. So chaza ukuthi lama forces lawa a horizontal yiwo azokunikeza u-F net, ne? Let's choose to the right as positive, ne? So izothi Tx minus Fk, ne? Tx minus Fk is gonna be equal to Ma, ne? It's gonna be equal to Ma. Now Tx is equal to T cos 15 degrees minus Fk, which is the value esifunayo, equal to okay, let's substitute. That's gonna be 8 plus 1,32. Remember, acceleration for the system, the acceleration of the system. Now what the acceleration of the system, it comes with the acceleration for the 2 kg block, the acceleration for the 8 kg block as of far. So lana for the 8 kg block, the acceleration nakhona kuzoba 1,32. So lana tension calculated as what? She calculated as 16,96. A substitute, so it's gonna be 16,96 multiplied by cos 15 degrees minus Fk equal to, okay, let's calculate this one. She calculated this one, 8 times 1,32, it's 10,56, and then 16,96 times cos 15 is equal to okay, I see express it in 3 decimal places, so let's just say 2. Since you go 2 fix into 2 decimal places, so lana is gonna be 16,38, lana it's minus Fk 10,56. Now lena ngitranspose ngapha le ngiletha ngapha, ne? Ngifuna ukuthi this one ibe positive, that's why ngiyisa ngale. Minus 10,56 equal to Fk. Now 16, it's 16,38 minus 10, minus 10,56. Sorry for the light. Answer it is 5,82 Newton equal to Fk. So Fk is in the opposite direction. We were expecting ukuthi ibe njani, ibe negative. Ngoba ekuqaleni already she accounted for the signs when we were setting up the equation here. That's why answer it iphume ibe positive la, ne? So Fk simtholile, this is our frictional force. Asibona ukuthi le question elandelayo ithini. Okay, lana 2.4, as the 8 kg block moves from B to C, the kinetic frictional force between the 8 kg block and the horizontal surface is not constant. Give a reason for the statement. Okay, yabona the 8 kg block nayisuka from B iza ku C. Le block izobe mhlambe seyihleli so nayifika ku C la. Yabona? So kuchaza ukuthi the string senzani, the angle between the horizontal between this line and the string izowenzani, change. So in other words, the normal force na izowenzani, change. And then I change so kuchaza ukuthi the horizontal, the frictional force between the 8 kg block and the horizontal surface will change nakhona. This is what I'm saying. This is what I'm saying. 2.4. 2.4. 2.4. Actually, a block it is a figure with point C, say make somewhere something like this. So le angle mhlambe singayithola say 20 degrees or ingaba less, we don't know, until we see what's happening la. 8 kg block, this normal force here change. So as well as calculate if frictional force, kinetic frictional force, he calculates as Fk equal to what? Mu k times normal force. If this value here change, kazani, cause with the frictional forces or is will change. So lana, it's because the normal force is doing what? It's changing. It's because the normal force is changing. Right, so now 2.5, the last question. 2.5, but well, the kinetic frictional force, wait, the horizontal surface on which the 8 kg block is moving is replaced by another horizontal surface made from a different material. Simple mark. Now, question 80, will the kinetic frictional force calculated in 2.3.3, this one, the value is calculated up, a change? Choose from yes or no, give a reason for this answer. Yes, it will change. Beg. Uma ngabe uthatha le block le uyibeka on a table, bese uyayipusha leyo block, bese ku calculate frictional force yakhona, bese ususa the very same block uyoyibeka eskontirini mhlambe, so or somewhere endleleni or estupini, bese uyaliphusha lelo block, ucalculate frictional force yakhona angeke afane because of why? Asibuyele kule formula again. Kinetic frictional force is calculated as the product between normal force and the coefficient of kinetic friction. So this product is nigga in kinetic friction. The surface, this value, the constant, the coefficient, is different for different surfaces. So coefficient of kinetic friction for itafula ngeke ifane ne kinetic friction for coefficient of kinetic friction for iskontiri. That's why I said yes, if friction is will change. Why? Because different surfaces have different mu k values. Ta-da! Okay, now thanks for watching. Nangabe unama questions, please washare lapha ku comment section, then we'll discuss. Thanks for watching. Nangabe you're new to this channel, please subscribe. Peace.